We go through our lives thinking what we see is what we get. But what if there's a whole other world, totally hidden from our senses? Well, back in the late 19th century, a few scientists accidentally stumbled upon exactly that. A whole universe of invisible energy, a secret locked deep inside the heart of matter itself. So, how did a cloudy day in Paris completely redefine reality? Well, believe it or not, this whole incredible story kicks off with what was basically a failed experiment, something just tucked away in a dark drawer that somehow ended up changing, well, everything. It's a story about a pretty frustrated scientist and some seriously stubborn clouds. So, let's get into it. Our story doesn't start with some big eureka moment. Nope. It begins with a weird, mysterious fog on a photographic plate. And that little shadow, that was the very first clue that our world was, well, way more complex and active than anyone ever dreamed. Okay, so to really get why this was such a huge deal, we need to set the scene a bit. The year is 1895. A scientist named Wilhelm Röntgen had just discovered these bizarre, mysterious things he called X-rays. And this discovery sent an absolute jolt through the scientific world. Suddenly, everyone was in a frenzy, a race to find other kinds of invisible radiation. And one physicist, a guy named Henri Becquerel, he thought he was onto something. And this is where it gets really interesting, because what he planned to do is totally different from what ended up happening. Becquerel's whole idea was pretty straightforward. He figured that if you blasted these uranium salts with sunlight, they would glow and give off rays, kind of like X-rays. So he wraps up a photographic plate in thick black paper, puts the uranium salts on top, and waits for the sun. But, it's Paris. The weather just wasn't cooperating. It stayed cloudy for days. Finally, he gets fed up, a little impatient, and decides to develop the plate anyway, probably thinking, what the heck, it's going to be blank anyway. And bam, this is the moment that changes everything. The plate wasn't blank at all. In fact, it was fogged over, and you could see a perfect, clear image of the uranium crystals right on it. But how? The sunlight, the thing he thought was the trigger, had never even reached the plate. The only possible conclusion was that the energy wasn't coming from the sun, it was coming from the uranium itself. Just like that, completely by accident, Henri Becquerel had discovered natural radioactivity. So Becquerel's accident basically opened a door to a whole new reality. But it was going to take a couple of other brilliant minds to actually walk through that door and figure out what was on the other side. And that brings us to the radium detectives. Enter Marie Curie. She was a young, incredibly bright Polish scientist working in Paris, and she was absolutely fascinated by Becquerel's weird uranic rays. She and her husband, Pierre, started this massive investigation, looking for anything else that might be giving off this strange energy. And it was Marie who came up with the perfect name for it, a name we all know today, radioactivity. Then, in 1898, after just an incredible amount of work, they made this huge announcement. They hadn't just found more radioactive stuff, they had discovered two completely new elements. The first one they named polonium, a tribute to Marie's beloved homeland, Poland. The second was even more powerful, an element they called radium, which literally comes from the Latin word for ray. And look at this number, 0.1 grams. Just let that sink in for a second. To get that tiny amount of pure radium, the Curies had to process literal tons of ore. They performed over 10,000 chemical operations, not in some fancy lab, but in a leaky, drafty shed. I mean, the dedication, the sheer force of will, it's just unbelievable. Okay, so we've got this mysterious energy. We've got brand new elements, but what is this stuff? Like, what's actually happening on a fundamental level? Time to dive into the science of it all. So when you get right down to it, radioactivity is all about transformation. It happens when the very core of an atom, the nucleus, is unstable. It's like it's just not comfortable how it is. So to get more stable, it spontaneously breaks apart. We call that decay. And when it does, it shoots out a burst of energy. And that energy is what we call radiation. But here's the thing, not all radiation is created equal. Another pioneer, a physicist named Ernest Rutherford, figured out that there are actually three main types. First, you've got alpha particles. Think of these as the heavyweights. They're positively charged, but they don't get very far. A single sheet of paper can stop them. Then you have beta particles, which are basically just super high-energy electrons. They're a bit more persistent. You need some aluminum foil to block them. And finally, there's gamma rays. These aren't particles at all. They're pure energy, and they are incredibly powerful. You need a thick slab of lead to have any chance of stopping them. And figuring out what these rays were, well, that led to the biggest revelation of all. This wasn't just a new discovery, it was a scientific shockwave that was about to shatter the very foundation of physics. You have to remember, for more than 2,000 years, going all the way back to the ancient Greeks, scientists had one core belief about matter, that it was all made of atoms. And the one thing everyone knew about atoms was that they were the smallest possible thing, the final building block. The name itself, atomos, literally means uncuttable or indivisible. And then came radioactivity. It was the scientific equivalent of an earthquake, because it was undeniable proof that the atom was not indivisible. Here you had an atom of uranium literally spitting out a piece of itself and changing into a totally different element. It meant the atom wasn't a solid ball. It had parts, it had a structure, and it could break. Physics would never, ever be the same. This discovery just completely demolished the old idea of what an atom looked like, the so-called plum pudding model. So Ernest Rutherford had this brilliant idea. He used those alpha particles we talked about as tiny bullets. He fired them at a super thin sheet of gold foil, and he expected them to just zip right through. But some of them, shockingly, bounced straight back. This proved the atom wasn't some soft, mushy pudding. It had to be mostly empty space, with something tiny, super dense, and positively charged right in the middle. The nucleus. And just like that, the nuclear model of the atom was born. And with it, the entire field of nuclear physics. Realizing that the atom could be split, that didn't just change a few science textbooks. It changed the entire world. It unlocked a future filled with both incredible promise and unimaginable peril. When you look at its legacy, you really see this is a double-edged sword. On one hand, it gave us things like nuclear energy, a whole new source of power. It led to life-saving medical tools like PET scans that let us see inside the body, and radiation therapy to fight cancer. But it also unlocked the secret to the most destructive weapon ever created, the atomic bomb. And to think, it all started with a fuzzy shadow on a photographic plate in a dark drawer. A simple mistake that peeled back the curtain on reality, showing us that the solid, stable world we thought we knew was just the beginning. It taught us that atoms can change, that matter is full of secrets, and that incredible energy is locked away inside. It really makes you wonder, doesn't it? What other huge invisible forces are out there right now, just waiting for their own cloudy day in Paris?